Okay, let's go over the molar volume of gases homework worksheet. And here you were supposed to calculate some volumes of gases. So in doing volumes of gases, I will say at this point, we've got some different equations so far. We got 6.02 times 10 to the 23rd particles per 1 mole equals question mark over question mark. That's one of the equations we've gotten so far. That was the first one in this chapter. And then we had molar mass, which was figuring out the molar mass of the substance per 1 mole of it. And then we say question mark over question mark to figure out from a question if we were given a certain number of moles. And then this one has to do with gases where there's 22.4 liters of a gas per 1 mole of that gas. And that's going to be equal to question mark, question mark. All right, so this is the one we're going to use today. So we are using 22.4 liters per 1 mole. The awesome piece of this, if you notice I'm already writing it up there, is because it doesn't matter which gas we're working with. It's always going to be 22.4 liters per 1 mole. So the first one we got 6.53 times 10 to the negative third moles of carbon dioxide. So I go to the other side, moles is on the bottom. So I need moles on the bottom. So it's 6.53 times 10 to the negative third moles of carbon dioxide. Switch up pens, I think that one's 9. And we're going to have X liters on top. So we're going to cross multiply and solve. So X times 1 equals 22.4 times 6.53 times 10 to the negative third. Now don't get tricked up on this and think, oh, this is times 10, so it must be that first equation. No, what you got to use the units. Because this is asking for volume, then we're going to use the one that has volume in it, which is liters. Right? So the only reason I write this is because way back when we talked about significant figures. So now if you multiply and solve this, you're going to get X equals 0.146 liters, and that was of carbon dioxide. All right. Any more black ones in here or not? Nope. Alright, so we'll go with the blue, because that one's starting to die. Alright, so that was the first one. Let's go to the second problem. Second problem, they gave us 0.754 moles of methane, CH4. So we got on the bottom 0.754 moles of methane. And we're going to try and find out X liters of that. So cross multiply again. X times 1 equals 22.4 times 0.754. So you multiply that guy out and you should end up with X equaling 16.9 liters of CH4. Make sure again that you tell me what substance it is. Don't just say 16.9 liters, right? Because I'm going to go like, liters of what? You got to tell me what the substance is. So in this case, CH4. All right, letter C on this one, we get 8.56 moles of nitrogen. So it's moles again, so that means it goes on the bottom. And it's what? 8.56 moles of nitrogen. And we want to find out X liters of that guy. Cross multiply, X times 1 equals 22.4 times 8.56. That's going to be a big number because we're multiplying it by 8. So this one's going to be 192 liters of nitrogen gas. All right, so that takes care of question number 1. So now when they gave us moles, and we had to find out liters. So now let's go to the second one. And in the second one, now they're going to give us liters, and they want us to find moles. So the first one, they gave us 147 liters of SO2. So we got 147 liters of SO2. We're going to find X moles of that guy. So we're going to cross multiply this times that. So 22.4 times X equals 1 times 147. Let's switch colors. That one seems like it's dying too. So we got to get X by itself, divide by 22.4, divide by 22.4. And you end up with X by itself. And X ends up equaling 6.56. And that's moles of SO2, sulfur dioxide. So that was the first one. All right, let's go to letter B. Letter B, they gave us 0.79 liters, 0.794 liters of helium, and we want to find out X moles of that. So again, we're going to cross multiply 22.4 times X equals 1 times 0.794. Now we're going to get X by itself. So we divide by 22.4 on both sides. That gives us X all by itself. And if you divide this out, you're going to get 0.0354. And that's moles of helium. Really small number because we didn't have very many liters of it. All right, let's go to the third one. Hope you notice that these ones are really kind of easy. You don't have any real calculations to do. It's all straightforward. Doesn't matter what the substance is now. All right, third one. They gave us 3.76 times 10 to the third liters of what stuff? C2H6. So we're going to find out X moles of this guy. Cross multiply 22.4 times X equals 1 times 3.76 times 10 to the third. So we're going to get X by itself, divide by 22.4, divide by 22.4. That gets that all by itself. So we got X all by itself now. So now you type this guy in, go 3.76 exponent 3. Remember, don't type in times 10. Right? And if you do that, you're going to get an answer of 168. And that's moles of C2H6 or butane. All right. So that's those ones. Now we get to the last one. What's the density of neon gas at STP? That's a hard one. And it really is. It kind of really makes you have to think for a minute. I gave you a little hint and said, hey, remember that density is mass over volume. All right. But we got to remember we're talking about neon. Well, we're talking about 1 mole of it. So what if I had 1 mole of neon? Well, where would I find out the mass of 1 mole of neon? Oh, that's the periodic table. We get its molar mass. So the molar mass of neon is 20. So that's 20 grams if I had 1 mole of it. But also I know that if I have 1 mole, it's 22.4 liters. So I can now set up that the density of neon equals its mass, 20 grams for 1 mole, is 22.4 liters. And then what I'm going to do from there is now I'm going to divide that out. I think I have it here. Yep. So you divide this out, and that density equals 0.893, and that's grams per liter. All right. Which, now, what in the world does this mean? Well, if I had some neon gas, where's it going to go in this room? Well, let's do some fun stuff here and find out. All right. I'm going to switch colors. So let's do, most of the air that's in this room is nitrogen. I know there's oxygen, but most of it is nitrogen. So if we want to find out the density of nitrogen, well, we need the molar mass of nitrogen. Well, there's 2 nitrogens because it's diatomic, so it's 2 times 14. All right, that would be its molar mass, and that's going to take up 22.4 liters. So that gives me 28 divided by 22.4. So what's the molar mass, or what's the density of that? Well, that's 1.25 grams per liter. So the density of the nitrogen that's in this room is 1.25 grams per liter. So where's neon going to go if I release it in this room? It's less dense, so it's going to go up. Right? What about helium? We know what helium does. So let's do density of helium. Well, the molar mass of helium, it's only 1. He's not diatomic, so his molar mass is 4 over 22.4. So we divide that out, and we'll get a density of 0.179 grams per liter. All right, so that's a really low, whoops, sorry on that. Let me move it over so you can see those. That's a really low density. So you compare that to the density of the nitrogen in the room, that helium balloon is going to go up really, really fast. And we've all seen that in regards to a helium balloon before. All right. Let's do one other one that I think is always kind of interesting, and hopefully you have one of these in your house, but a carbon monoxide detector. Carbon monoxide, so we got to go back on this and go, what's the formula for carbon monoxide? Carbon monoxide is CO, carbon and 1 mono oxygen. Carbon monoxide is a very dangerous gas. If it's in your house, you can die if you breathe too much of it. So let's find out, if you have a carbon monoxide detector, where should it be in your house? Should it be on the ceiling because the carbon monoxide goes up? Should it be down on the floor because the carbon monoxide sinks? Or where should it be? And it's all dependent upon this number over here, that density of the nitrogen gas that makes up most of the air in the room. So if we do this thing, we got to do molar mass of this. Well, there's 1 carbon, so that's 12, plus 1 oxygen, that's 16. And then we're going to go 22.4 liters. So these two add up to 28 grams. Ooh, come on. So if you figure out that density, it turns out to be 1.25 grams per liter. How does that relate to the density of the nitrogen in the air? It's the same thing. So where is carbon monoxide going to be in your house? Anywhere, right? It can be at the ceiling, it can be at the floor, it can be in the middle of the room, it can be anywhere because it's the same density as the density of the nitrogen that makes up most of the air in your room. So where should your carbon monoxide detector be? It should actually be right about here at the area where you predominantly are, right? So that you can detect it where you're going to be breathing at. You don't necessarily want it at the ceiling, you don't want it at the floor, you want it right in the middle of the room as to where you're going to be. And it's all because its density is the same as the air. All right, well, that concludes this homework assignment. Hopefully you did learn something, and hopefully you'll go out and get yourself a carbon monoxide detector, because you do want one of those in your house to make yourself safe. So we'll see you. Have a great day.